Hello fellow Scratchers! This is part 2 of our Scratch RPG tutorial, and man, this episode promises to be a stonker. Sure, we have our player sorted from episode 1, but the substance of our RPG relies upon the creation of a seamless, persisted, tiled, scrolling level. Wow, the things we are going to learn! Beginning by covering crazy simple infinite scrolling backgrounds. Yeah, infinity sure does go on a very long way. Then we'll talk about level maps using Scratch lists, before coding a working grid list solution to power our stamped scrolling engine. Finally, for those who think Griffpatch and lag never doth they meet, stay tuned to the end of the video because, yes, the lag is real! But fear not. Where we are heading, we'll say goodbye to lag for good. Yep, silky smooth scrolling. I promise. Hey, talking of lag, some of you have commented that loading these big projects in Scratch can be real slow, so here's a handy hint. Don't click the See Inside button from the My Stuff page. Watch how slow this is. I'll leave that loading, and in the meantime, watch how fast it loads if we instead click to view the project, like this. And then, my goodness, does it load a lot quicker. And then we simply click to see inside, and there we are. Yep, the screen is still loading. Right, with our projects loaded, click to save as a new copy. For this is episode 2. Guys, let's get scratching. So, last episode, we got as far as getting our player to walk around and animate, and that is great. But this is supposed to be a scrolling game, so let's see what we can do about that. A scrolling effect is achieved by not moving the player, but moving the entire scene around too. So, the grass will have to move left. Oops! Did you know that dragging a sprite on the stage causes it to move in front of all the other sprites? Now it's in front of the player sprite too. Oh! Not to worry. Click back into the player sprite, and under the When Flag Clicked script, drop a Go to Front block right after the set size. That'll make sure the player stays at the front. Okay, player X and Y. Keep track of the player's position on the level. Now we will add some variables to keep track of the scrolling viewport, the camera position, if you will. Create a new variable, CamX, for all sprites. This stands for camera X. And we create CamY, also for all sprites. We can test these out by right-clicking the variable reporters on the stage and changing them into sliders. Find the When I Receive Paint Player script. Now to scroll the sprite around using the camera sliders, we just subtract CamX from player X and CamY from player Y. This simple change gives us the power to pan the player around the screen independent of the normal movement scripts. But to complete the effect, we need to move the background grass sprite too. So click into the background sprite. We'll add some general setup scripts first. When flag clicked, set size to 200. Yeah, all my sprites are 200 in this project. So bring in a When I Receive event receiver. And we'll add a new message, paint background. Now we go to XY, and we subtract from 0 CamX. And the same for the Y. 0 subtract CamY. To make this all work, we just need to broadcast this new event. So back in the player sprite, find the Start Game Loop script. Add a new broadcast block for the event Paint Background, and we drop it in here before the Paint Player broadcast. And this way, the background will be drawn before the player. Excellent. Let's test it out. Smash that green flag, and we have some fun wiggling these camera sliders and watching the player and the grass now scrolling around together. Beautiful. And yes, we can still walk around using the arrow keys as long as we click off the variable reporter first. It's nice that the scrolling and the player movement are independent, as the player will not always want to be locked to the center of the screen. However, that might be the exception rather than the rule. So, in the player sprite, under the tick player receiver, set cam X to player X, and set camera Y to player Y. Now the camera is locked to the player position, following along as we walk. But it's great that we have the flexibility to break away from that later on. Now it's a shame that the background costume is so small, and we reach the end so soon. It'd be nice if we could make it go further. Luckily, there is a trick for that. Click into the background sprite. Now you see, this large grass costume is made up of a repeating pattern of smaller grass tiles. It repeats seamlessly every 32 pixels. Now this costume at 200% is a full tile wider and taller than the stage. That means we can scroll it smoothly across by a full tile, 32 pixels, but here's the trick. Before scrolling further and revealing that ugly costume edge, we jump it back to the left by a full tile width. The magic is that the player isn't even aware that we did it, and this creates a perfect infinite scrolling background. And it's easy to script. In the background sprite, we replace the camX with a mod block. CamX can be placed on the left, and on the right we enter the width of a tile, 32. This will now loop the camera position around so it never reaches or exceeds 32. We want to do the same for cam Y, mod it by 32, and subtract the result from 0. Are you ready for this? Green flag time! And would you look at that? You wouldn't know the tricks going on behind the scenes, would you? Just looks like a sweet scrolling background. If you want to see the costume being shifted around, then you can set size to 100. And there you go. You can see how the costume is just shifting back and forth. I love it. Now back to 200%. So wow, we could do a lot with this. But to populate our world with exciting roads, buildings and more, we'll need an upgrade. Yes, we're going to talk about tiles. So for now, hide the background sprite and we'll click into the tile sprite now. You may or may not be planning to use the same tile costumes for your RPG as mine, but whether you are or not, we should try to understand how I've laid them out. You'll find the first actual game tile doesn't start until costume 20. More on why in a moment. But each costume has a width and height of 16 pixels, which at a size of 200% ends up as 32 by 32 pixels in the game. This is just a great size, not too big and not too small. The costume itself is a bitmap and is centered on the canvas. This makes it really quick to import the new costumes. So what about all those other costumes before this first tile? Well, there's a big costume. This looks empty, but is actually a large transparent rectangle. We use it to allow other costumes to move easily off screen. The next costumes are going to be used in the level editor in future episodes. I can't wait for that. And then you'll also find the rest of the costumes are blank, and they're named reserved. You see, we may need more costumes for other editor features later on, and these reserved costumes can be replaced as and when we need them without changing then the costume number of tile 20. You see, changing the costume numbers of tiles already used in our game will lead to broken levels, and we don't want that. Well, okay guys, let's make a start. We need the obligatory sprite setup code. When flag clicked, set size to 200, yep, and then hide. No need to have the original sprite visible on the stage. Then, when I receive, paint background. Now we are wanting to paint a grid of tiles to the screen, like this. So we'll need a new custom block, named paint, with run without screen refresh checked. This will allow it to paint all the tiles quick enough before the screen refreshes. Drop the paint block under the paint background receiver. Nice, let's start simple, and just paint one line of tiles. Switch costume to the first actual tile costume, and for me that's tile 000, right after that line 18 costume thing there. For now, set X to 0. And we'll paint one row of tiles, so repeat 10. Often at this point, we would drop in a create clone block, but nope, not this time. The reason I keep naming these events paint is that we are going to paint these costumes to the screen. So click on Add an Extension and choose the Pen extension. And now we can stamp the sprite on the stage, literally painting a copy of it on the screen. After which, we move on to stamp the next tile by changing X by 32. That's the width of our tile sprite, if you remember. Great, let's see that working. Just click the Define Paint script. And yes, that's cool. We've stamped a seamless line of tiles from the middle of the screen to the right margin. Well, almost seamless. The last tiles have experienced somewhat of a pile-up at the edge of the screen, and this happens because of Scratch's fencing rules that prevent you moving a sprite fully off the screen. Oh, bother. Well, what we'll do to get around this is to switch to a big costume before we move, because big costumes are allowed to move further off screen. So we'll move to where we want to go before switching back to our smaller costume again. Perfect. So duplicate that switch costume block, and now change the original costume to be the big costume, minus costume 1. This is then moved into position, and before we stamp the tile, we quickly switch to the actual costume to be stamped. Then, right afterwards, switch back to the big costume, ready for moving once more. To test that, click the paint block again, and there we go. Bug squashed! Right then, for a complete grid of tiles, we just need to stamp more of these rows up the screen. Separate off the set X and repeat loop that drew that row. And we begin with a set Y, again to 0, and then repeat 10 times for the 10 full rows. These scripts go back inside this new repeat. All we need to do though is make sure to keep moving up to the next row using a change Y by 32 as the last block in the outer loop. Now this is exciting. Click the paint script again to run it, and let's see what we've got. Yeah, very promising indeed, and don't be worried about it feeling slow. If we clear the screen, that's in the pen category, click on the Erase All block there. So if we now click the When I Receive block up here, bang! Instant tile painting. Much better. It only draws slowly when we click on the Define block itself, and that's because running a block directly ignores the Run Without Screen Refresh option. Great for testing, but it can be a little confusing if you didn't know that. For now, we'll place an Erase All block at the top of the paint script to clear things up before we begin painting. Now, one thing we haven't yet addressed is scrolling this tile grid with the camera. No problem though. Just as before, we take the set Y block and carefully, to use cam Y for the Y position, replace 0 with 0 subtract cam Y. And do the same for the set X, replacing 0 with 0 subtract cam X. And then, excitedly slap that green flag and bask in the glory of this beautiful scrolling grid of tiles. Nice work! But we are not quite there yet. Click the green flag to reset the project, because things are not yet positioned quite as they should be. What I would expect to see is this. Since we start by setting player X and Y to 0, 0, the player should be snugly positioned at the bottom left corner of the bottom left tile of our level. So why are these things not aligned correctly? Well, it's down to our costumes. If we position a tile sprite at an X and Y of 0, it appears here, because the costume is center aligned. What we actually want is for it to appear here, half a width and height across and up from where it is. So unless we want to edit all 500 plus costumes, let's do this in code. Find the 0 subtract cam Y. And to add 16 pixels to this, we can just write 16 subtract cam Y. And for the X, set X to 16 subtract cam X. Simple. Tap that green flag and we can confirm we are getting closer to our goal. Next up, the player sprite. In the costume editor, we can see that they too are center aligned, but it's not as simple as moving them up so that their feet are in the center, because this is a semi-3D world we are simulating. Imagining them inside a 3D block helps a bit. Their feet are therefore actually around here, so we have to move them up by 10 pixels, and that should do the trick. Again, leave the actual costume alone. In our code, find the when I receive paint player script. We need an addition block, and we'll add to player Y an extra 10 pixels. Return that to the set Y block. So, has this sorted the positioning? Green flag time? And yes, this is looking much more as expected. So, we can safely move on to greater things. Enough of the same repeating tiles, I think. We want to define a full level map, recording what tile costumes appear where. So, who watched my tutorial on grid lists? If you haven't or need a recap, then do give that video a watch. But basically, our goal is to store a level map, like this one, in a scratch list. Let's take a smaller example. We can't store costumes in a list, but we can store costume numbers. So, starting at the bottom left, this bush is costume 79. Pop that into the list. And then we work our way across the first row, filling out the costume numbers. All bushes. Once a row is complete, we simply continue on the next row above, left to right. The plain grass is costume 44. And we continue, cell after cell, row after row, until we've completed the entire grid. Perfect! Let's do this. We'll start by creating a grid list exactly like this one. So we're still in the player sprite, so find the when flag clicked script. To trigger the loading of our grid list, broadcast and wait, important because we must wait for the level to load before continuing, and use the new message, store load scene. I begin with the word store to indicate this event is handled by the level storage code. Indeed, we can create a new sprite for this now, naming it level store. All level loading, saving, and generating will go in here. So when I receive store load scene, we can add actual loading scripts later on. For now, we'll just generate a level. Make a new custom block named new map. Run without screen refresh. Drop the new map block into our event, and we are ready to generate our grid list. Talking of which, make a new list and name it grid, leaving it for all sprites. Start with a delete all of grid to ensure that it's fresh and ready for us to use. Before we begin, we need to decide the width and height of our grid. Make a new variable for this named gmax, grid max for all sprites. And for consistency, let's set gmax to 10. This will generate a 10 by 10 cell grid. Now let's add this first row of bushes. Repeat. For gmax, that's 10 items, adding to grid, the bush costume. Except I feel we're going to be adding a lot of runs of the same costume. Let's make this repeat add into a custom block. Name it add to grid, with an input count. That's the number of tiles to be added in a line. A label of tiles of, with the input tile. That's the tile to be repeated. Run without screen refresh. We can then move the repeat into here, using the count input in place of gmax, and the tile input is the costume number to be added to grid. Nice! It's now simple to add the first row to the grid. We just say add to grid gmax items of costume 79. That's my bush costume. We can test that works by clicking the new map script, and we should see 10 items of 79 appear in our list. The next row begins with one bush, so add 79 to grid. This is followed by a run of grass. How many? Well, 2 less than the full width. So add to grid block 44, that's the grass, with a count of gmax subtract 2. And don't forget to finish off with another bush. Add 79. That's the next row completed, so clicking the script should add another 10 items to the end of our existing list. Great, so we just need to repeatedly add more of those types of row, so pop that in a repeat block. And the number of times to repeat is again 2 less than the full height, which is gmax subtract 2. Lastly, to complete our level, we add another full row of bushes. Add to grid, gmax tiles of 79. If all is well, running the whole new map script will now result in 100 items in our grid list. Brilliant! We are ready to boogie! We can hide the grid list and click back into the tile sprite, ready to make use of this list to paint our tiles. We begin painting grid tile 1. We need a variable to keep track of this and name it GIDX. That stands for grid index. And make it for this sprite only. And set GIDX to 1. Pop that in at the top of the script. Now we are switching costume here, so bring in an item 1 of grid. Now we want to pull the costume number of the tile at position GIDX out from the grid list. Then to move on to the next list item, change GIDX by 1, just before the end of the inner repeat loop, like so. Oh boy, you know what time it is? It's testing time! Smash that green flag! Yes, yes, look at that! That's exactly what we were hoping for. Aren't grid lists the best? So, being the curious scratchers we are, our next thoughts might be to wonder, well, how big can we make our grid list level? Let's find out. Click back into the level store sprite. Our level is 10 by 10, so now set Gmax to 100. That's 100 times 100, 10,000 tiles? Gosh, do you think our stamping script can handle this? To find out, we must click into the tile sprite once more because our stamping repeat loop is still set to a fixed 10 tiles. We need to update this to use the Gmax variable in both cases. So before I run this, what do you think? Do you expect stellar fast performance or terrible sluggish super lag? Well, sadly it's the latter. Asking Scratch to stamp 10,000 tiles is far too much for the poor thing to handle. This is a problem for us. But just wait a minute. How many tiles are actually visible at a time? Certainly not the full 10,000. I'd say we're only seeing 100 to 200 tiles on the screen at once. The rest are out of view. What do you say to us optimizing our script to only paint the tiles that are actually within the screen bounds? For the time being, just pop back into the level store sprite and set Gmax back to 32 to curb the unbearable lag, as I'm afraid this is all we have time for this week. If you enjoyed this video, then please smash that like button and subscribe to the channel now to ensure you don't miss the next epic episode. It's going to be awesome as we optimize the tile engine to run literally hundreds of times faster. Believe me, I'm excited. Are you? If you can't wait, then you might consider joining the Early Access membership to be one of the first to see episode 3 before everyone else. Let me please just show my appreciation to my 3 biggest Patreon supporters: The Random Person, Minecraft, and Creep2Craft. Thanks so much to you guys and all my other channel supporters. You guys are the best. And on that note, we must finish. Thank you for watching, have a great week ahead, and scratch on, guys. Then, when I receive paint background,